Since this course uses Linux as its base operating system, we need to spend some time kind of getting up to speed on Linux. Now, I know that a lot of you already know Linux pretty well, but the other half of the class does not. And so if you already know Linux, please bear with me. And if you don't know Linux, don't be afraid. This is a pretty gentle tutorial to get you through the material. So first, before we even get to Linux, we need to talk about Unix. And Unix is an operating system similar to Windows and so forth. It was developed at AT&T Bell Labs in the 1960s, and it centers around a command line interpreter. Now, if you've ever been a DOS person back in the old days in the early 80s, late 70s, early 80s, pretty much DOS was centered around a command line itself, the DOS prompt, the famous DOS prompt. Well, Unix itself is also centered around command line too. And Unix and Linux have actually kept the tradition alive, and although there are quite a few graphical user interfaces such as Ubuntu and stuff to put on top of Linux, there's also a really good reason to continue using the command prompt in Linux because some things are just easier and more clear. So Unix versus Linux. Let's take a brief moment to explore the differences. Unix came first. It was the commercial version, the commercial operating system. Linux came after Unix. Linux is a variant of Unix, so they're very similar. Even the Mac OS X is based on Unix. I'm not sure exactly what version of Unix it's based on. There are a number of Unix variations too. But a lot of this tutorial actually applies to Macs as well as it will to the Ubuntu Linux, which we're going to be using for these examples. So Linux is open source. You can grab the whole thing. You can make your own distribution that specializes in certain things. A couple of examples of this are the Paladin distribution, which comes with a lot of forensics tools. And we use that in 5131, and we're going to use it quite a bit in this course. So it's completely open source, which means you can make your own distribution for whatever you need. Many of the machines you'll use while at UCF, in the UCF program are running the Linux operating system. So you'll see it all over the place. So why Unix or Linux for this course? Why are we doing this? Or why would you even consider, as a practitioner, why would you consider using Linux? Well, it's free, it's fully customizable, thus we have builds like Paladin and Kali, which are going to really help us in security and forensics endeavors. It's stable, it almost never crashes. It's fairly secure too, and that's another reason that we're going to use it for forensics. And it just has a lot of the tools that are really easy to use and really readily available for our forensics investigations. So these characteristics make it an ideal operating system for programmers and scientists and forensics investigators. So for most of these basic Linux tutorials, we're going to be using Ubuntu build 16.04. Now for a lot of the forensic stuff we'll be using Paladin and Kali. But I feel like it's a lot easier to use Ubuntu since it's pretty much unadorned Linux. So I've installed this in a VMware machine, and if you need help doing that, last week I actually created a whole video that showed how to create VMware machines for Ubuntu, Kali, and Paladin. Okay, so let's go ahead and log in here. Pretty simple. And then the Ubuntu desktop comes up. So now that I'm logged into Ubuntu, let's take a real quick look around. And this looks like a graphical user interface, not that dissimilar from Windows. Let's run this. And this looks a lot like Windows. You've got the desktop, documents, downloads, and so forth. I mean, almost identical to what you'd see in Windows here. And that's all really nice. If you're a sort of a casual Linux user, then this is all you need. You can store all your pictures and downloads and stuff here. But that's more for the casual person, the casual user. So what we really need to do, and that's okay. I'm not saying anything is wrong with that. But what we're going to use more than anything is going to be the terminal for command line. And there are a couple of ways you can run that. You can say Control-Alt-T, and it'll come up. Okay. You can go here and you can search for it. You can say terminal, and then click there. So either way is fine. You can actually also lock it to the launcher so it's always visible here, which I'm going to go ahead and do right now. So it's always going to be there even if I bail out of it. I still have an icon shortcut to it. Linux has a hard drive hierarchy that we're going to take note of right now. And the reason this might be important in this class is because you might be doing different things that require you to understand these. Here again, if you're a casual user, it really won't make that much difference. But here I've got a list of the required Linux root folders or directories. So the first one is bin. This contains essential command binaries, ls, chmod, and so forth. Boot contains static files of the bootloader, so in general you're going to want to leave all those alone. Dev is device files. Everything in Linux is a device file. Or I mean all sort of I/O that you do is done through files. etc, or sometimes etc, host-specific system configurations, so you won't see binary data in there very often, or probably not at all. Lib is going to be essential shared libraries and kernel modules. You will probably leave those alone. You may add your own. Media is mount point for removable media. MNT is mount point for mounting a file system temporarily. OPT, add-on application software packages. Okay. SBIN. So SBIN and bin are slightly different. SBIN is going to be the essential system binaries, which you really really need to be left alone because the system relies on them. Bin, you might put your own in there, sort of reshuffle them or add other versions, but SBIN you really want to keep your distance from. SRV, data for services provided by the system. TMP, temporary files. USR, secondary hierarchy. And var is variable data. So let's take a look and see if we can find these folders, these directories. I don't see them there. So that might be a little bit disturbing, but what happens is in this graphical user interface, the idea is to hide those from the casual user. Let's go ahead and open up a terminal. And the command I'm going to be using is ls. It's somewhat synonymous to the dir in the Windows command prompt. So if I say ls, I'll see all the files in the current directory. Okay, so I see several folders, several directories, and then examples.desktop is an actual file. And Linux is pretty good at color coding the entries in a directory so that you can easily figure out or identify or narrow things down. Okay, so if I say pwd, that's going to tell me where I currently am. Okay, so I'm in my home directory right now, home r/Lineker. Now, similar to Windows, Linux is going to give each different user their own home directory. And that's so you can keep, you can have like distinct desktops, distinct data, documents, and so forth. downloads. So it's the same idea that each user who logs in here has their own set of private data for them. So anyway, but here again, you don't see those special folders, directories that I talked about. So we've talked about two commands, ls, pwd, which we're going to go into more detail. Actually, we really don't need to go into much more detail on pwd. That's just going to show you where you currently are. Okay, ls, there are quite a few options, and we'll get to those eventually. But now we're going to use cd or change directory. Okay, so in Windows, you're usually going to use backslashes. Here in Windows, normally use forward slashes. So if we do this cd and then a single forward slash, what that means is bring us to the root directory. Okay, we say ls. Now I see those special directories that I was mentioning before. You see several others such as lost and found, and maybe CD-ROM and things like that, which I did not mention just because otherwise we'll be here all day talking about these folders. So anyway, you see that those special folders that I told you are here off the root, and they're hidden from the casual observer. Okay, now that we're here, let's do pwd just so we can see where it thinks we are. Okay, it thinks we're at the root. Notice there's a single forward slash, which means root. Okay, so let's do an ls of the bin folder, the bin directory. Okay, and you can see that inside of there are a lot of the command line tools that you're going to be using. dd, df, ls, mkmod, and so forth. So you can actually make your own commands or your own little utilities and throw them in the bin directory too. Okay, so back here, that's what we're seeing. ls dev. Okay, so you see all the devices that it's created. Let's see. ls usr. And USR actually has a number of subdirectories too. Let's get rid of all this stuff. Okay, ls boot. You want to steer clear of this directory. ls etc. Okay, and so forth. So I encourage you actually to take some time and explore these very important directories that come with Linux. Okay, so let's go ahead and start using the terminal. And you might notice here that it says rlineoccur at Ubuntu : and then there's a little tilde to the right of that. What that means is that I'm in my home directory. If I do pwd, it will show that I'm in /home/rlineoccur. Okay. Now, before we even get started on any of these commands, there's a way to get help with them. If you say man and then ls, you'll get help on the ls command, and it gives you a really nice way to kind of scroll through it, read it. Okay, so it's a real nice interface. Okay. Now, you can also get help by saying ls -- help. This isn't quite as convenient because it just scrolls off the page and you have to scroll up to read everything. But if for whatever reason you get off and you don't exactly know what to do, go ahead and get help with the man command or with -- help. Now, to clear a screen, you just type clear, and it will clear everything on the screen so you have a fresh start. It's similar to the CLS from the Windows command prompt. All right, so first, let's review something we've already done, pwd. It's a simple command. It just shows you where you are. cd means change directory. So if I want to go to the root, I say cd /, and what that means is it's the root. But if I want to say go into the USR directory off of the root, I do that. Okay. And notice the command prompt. The prompt is actually reflecting where I am. So let me go back. Home, R. Lineker. So let's take a look here. Okay, so I don't have to do a / each time and type the whole path. We have a relative path, so I can do a relative path CD desktop, and what that's going to do is it's going to change directory. Oh, it's case sensitive. You can obviously tell my Windows roots, but what it's going to do is say, okay, wherever I am, I'm going to go into the desktop from that relative location. Okay, and if I want it back out a directory, I say cd dot dot. Cd dot dot is going to back me up one directory. Let me go back into desktop. I can also say cd dot dot / dot dot, and that's going to back me up 2 directories. Now I'm in home, but let me get back into R. Lineker. So that's just sort of a short summary of CD. Here again, you can go ahead and get help, and you don't get much help here. Man, CD. Okay, no manual entry for CD. Okay, so that's CD. You're going to use it a lot, especially when you're navigating through these folders, these directories. LS is another one that you'll use a lot. Basically, it's similar to the Windows dir command. Okay, here it showed us the folders, the directories, and one file. If we say CD desktop, shouldn't have anything. Okay, so now I'm going to go ahead and copy something. I should be able to copy directly from Windows. So let me go ahead and do that so we have something on the desktop to work with. Pictures. Okay, so now there's something in the desktop, which I just dragged from my computer. And so now I see untitled.jpg. So it's really nice VMware. You can actually drag stuff directly onto the desktop. Okay, and I'm gonna copy a bunch more files out here, but I'm gonna snip this so you don't have to watch me doing it. Okay, so now I have some files on the desktop, and if I do an ls here, you can see the loose files. There's some JPEGs. There are a couple of MP3 files, which are Alice in Chains music. You can see the pictures are the Porsche 928 I used to own. So there are 2 really fun days when you own a Porsche 928. The day you buy it and the day you sell it. Kind of like having a boat. Okay, so you can see what I see in the desktop, looks like maybe what I'd see on a Windows desktop, but here I have ls to explore it in a different way. So let's do ls-l, and ls-l is going to give us a list format with a lot more information than just a simple ls. Notice it starts off with giving you the permissions, and there are actually different types of permissions. There are 3 groups of permissions, which we will talk about next week. So it gives you the permission grouping. Okay, it gives you the owner and the group. Okay, and then time and date, size, things like that. Okay, so the A flag, the A prompt is something which is going to show you all of the files. ls-la. See, now you can combine these flags and switches too. Okay. You can actually sort them in different order. ls-l sort. Oops, misspelled sort equals time. So ls-l sort equals time. So ls-l sort equals time. Okay, so you sort by time, sort by size. And here again, if you go to ls-help, it'll give you all of the ways that you can sort. Okay. All right. So that's it for ls. Let me go ahead and okay. Okay, so sometimes it's important for you to know where stuff is located. If you type which, if you type which, and say mkdir, you want to know where that command is, it'll tell you the path to that command. Sometimes, however, you want a lot more information. You want to know maybe where the help is. You might want to update it. You might want to change it. You might want to know information about it. So we'll say where is, and then just where something is. So we'll use where is, and this will give us a lot more information, such as maybe where the help manual is. We might want to change it or edit it or amend it or something. So here it tells us make dir, where it's located, where the manual is, and so forth. Okay. Find is going to help you locate things within some sort of some hierarchy. So find is going to help me find a file somewhere. Let's say I want to search my home directory, desktop, untitled.jpg. So it finds it there. Command locate is similar. Locate is similar. Okay, echo is going to put something out on the console. Just have a single letter. Okay, and a lot of times that's good for when you're creating scripts. Okay, the cat command is going to concatenate two files. So let me go ahead and get into the desktop. Okay, so this is going to be kind of similar to what we did in 5131. So we're going to say concatenate cat, and we're going to put two files together. Let's see, dscf1033.jpg and dscf1035.jpg, and we're going to put that into couple.jpg. Okay, and you notice a new JPEG showed up. Okay, ls, and let's just take a look. So notice that couple.jpg is actually twice as large as all the other JPGs, and that's because we concatenated them into one JPEG. Okay, CP is copy couple .jpg other.jpg. Okay, so CP is just copy, and you can actually give it, copy it back up a directory like that, or you could say slash. Anyway, that's a good example. So that copied it back up a directory, which you can't see since we don't have, we're looking at the desktop. Okay, MV is move. So if we say move, move a file, let's say move untitled.jpg, make that capital U. If we move it up a folder, up a directory, you notice it disappeared from the desktop. If I go here and do ls, I can see that untitled.jpg is there. Okay, so that was move, mv. Okay, mkdir. Mkdir stands for make directory. Test 1, 2, 3. So you can see on the desktop I've got test123. If you look here, you can see I've got test123 as a directory. Okay, so going back to 5131 just a bit, we can actually go ahead and send stuff to files, ls file list.txt. So we didn't see the ls, but the ls results went into this text file here. Okay, and remember what we said last semester in 5131 is sometimes when we're collecting information, piping stuff into, say, a file is a really good thing. So just remember that. So df is going to report disk space usage. You can actually give it an argument if you want for another device, but anyway, this is going to give you what's available on the different devices. So du is going to estimate disk file usage. Okay, and that might be really useful if you're, say, looking at a flash drive or something, whether or not you can copy stuff out to it, or how much is actually there. Okay, one last thing before I quit Ubuntu and go into Paladin. So if I click here and I want to quit, it gives me several options. Suspend and power off are the two I'd like to focus on right now. Power off is it's gonna be like turning this machine off, and everything you've done will be lost. Everything will be sort of restarted. Everything will be not just restarted, but as it was when you set it up. If you do suspend, actually, these files I have here on the desktop will remain there the next time I come back to it. So anything you've done that you want to save, make sure you hit suspend, or if you just want to sort of clear everything out and start fresh, say power off. Okay, I'm going to say power off since I haven't done anything really special, and it'd be really nice to get these files and folders deleted, so I'm going to do that. So I just want to tell you, you have two options. Okay, so now we're going to move into a time when we're going to talk about creating images of devices and then restoring those images back to devices. So what I did was I created a USB device here, and it's just formatted with FAT32. And I have 3 song files, 3 image files, and 3 source code files on it. Okay, and I'm gonna image this, and then we'll once we've imaged it, then we'll go ahead and take that image and create a new flash drive out of it, new USB device out of it. But before I even do that, I want to do a couple of things. So once again, the reason we're going to be doing these extra things is so that when we move over from restoring the device from a backup, that we actually have it for sort of our starting forensics investigation, so we can kind of work through using some of the tools that are available. So let's create a 4th image. And it will be paris4.jpg. And note that this is going to be a concatenated file. I'm going to hit refresh here. Okay, so we see, notice it's larger than the other two, than all the other JPEGs. Okay, so now we have something that we can use to data carve. So let's go ahead and start deleting a few files. Let's delete this file. Delete this file, we'll delete that file, so let's delete those 3 files. And that way we'll have some files that we can work with in order to try to undelete stuff. Okay, so we've got our flash drive, and that's the easy part of it. Okay, so here I am at Paladin. I'm all booted up, and I'm going to go ahead and run the toolbox here. Okay, I'm going to go to the disk manager. You can see a list of the devices it sees that are available. Okay, now I'm going to plug in my USB device, and it's going to come up, and now you can see it there. And it's important that you note what the name of the device is. Okay, SDB is the actual device, and SDB1 is the actual partition. Okay. So I'm going to go ahead and leave this open for right now. I'm going to minimize it, and notice that Paladin automatically comes with the terminal icon because it knows that you're going to use it a lot. Let's see where we are. Okay, we're on our home directory, which is fine. I'm actually going to go ahead and go to desktop though, just so that it'll be a little easier for me to see from the GUI what I'm doing. So now we know we've got the USB device as SDB, okay, and we're going to use the DD command. And here again, if you do help DD, will give you a lot of help. What we're going to be doing now is creating an image based on that that USB device. Okay. So the first thing I need to do is make sure that I'm going to use sudo so that there are no access restrictions. And the input file is going to be dev sdb, and the output file we're going to say is going to be sample image. Okay. I forgot to put dd in front of sudo nif, so sudo dd is the actual command. dd is the command, and we're going to run it as system operator. Okay, so it goes through, it spins up, and it's doing its thing. And this actually will take a while because it's doing a bit for bit copy of that USB device. Okay, so now I'm done, completely done with what I was doing. And you notice on the desktop is the sample image, and that's essentially why I like to work from the desktop, so that I can actually see what I'm doing there. And here's the end of the command prompt that I ran. Okay. All right. Let's go ahead and get rid of this. Get rid of this. Okay, so the next thing I want to do is I need to go ahead and restore. I want to go ahead and restore this to another USB. You know, as it turns out, you never want to operate on your primary device. So that's the whole idea of making images. Because if you do, you may make a mistake and you've ruined your evidence. So the first thing I'm going to do to safeguard the USB stick I was using is to pull it out of the computer. Okay, and I'm going to set it aside, and then that way there's no way I can possibly, well, I guess there is a way, but hopefully I won't. Hopefully I won't mess it up. Okay, now I've got a new USB device I'm going to plug in. And there are a couple of things we have to do. You'll notice once we get back here, you'll see SDB. This is pulled it up again, named it the same device, which is fine. Just like Windows, when you put USB devices in, a lot of times it'll sort of reuse the same name it was using for the last time you plugged in. But what we want to do is now we want to prepare this thing. We don't want any kind of residual information on this. So what we have to do is wipe it completely. Okay, are you sure? And we don't want to verify. Well, I'm not going to verify the wipe. You could if you wanted to. It just takes a lot longer though. So I'm going to say no, and the process will start up. And you can see it's going to go through, and it does a really good job. It'll completely wipe this USB stick that I have plugged in and remove any kind of residual data that it might have. Now, this will take a long time. So what I'm going to do is snip the video, the recording, so you don't have to sit there. It's 10 or this is an 8 gig stick, so it's going to take 8 or 10 minutes, probably, maybe even more, maybe 15 or 20 minutes. Okay, as you can see, the wipe has been complete. There's no partition, it's just the bare drive. Okay, so let's open a command prompt, terminal. And there we have sample image, which is the image that we made. Now we're going to use DD to do the restore. Same format, except this time IF equals sample image, OF equals dev SDB. Okay, so we're just reversing these things now. Okay, and this will take a while. So while it's doing that, I will let it go, and I'll snip a good bit of this out of the recording so you don't have to watch it doing the restore. And what we could do is go out here to the toolbox and check Disk Manager and just see. Okay, there it is. All right. Okay, so what we need to do is get a hash of that USB device. Oops, sudo. And what we're going to do once we get this hash, we're going to compare it with the hash of the original USB device. Very important these match. If they don't, your evidence will never hold up in court. Okay, so there is the hash that was created, and I'm going to write down the last number of digits. 5860 CBB. Actually, what I should have done was this, and that way it would be stored. But I'm not going to do that since it takes so long. Okay, so I'm going to plug in the original USB device so I can get a hash of that. Okay, let's go ahead and check the toolbox, make sure it's plugged in. Reload this. Okay, so I just unplugged the imaged USB device. Now I'm going to plug in the original. And what we're going to do is go ahead and get a hash for that. That is not what we want. We want sudo md5 sum dev sdb. Okay, and this is going to take a while to do, and I'll go ahead and snip video out so you don't have to watch it. At a command prompt calculating an MD5 hash. Okay, so the last thing we're going to do is look at both USB devices plugged into Windows. So here I've got my F drive. It's got these 3 Paris pictures, 2 songs, 2 source code files. Click on device E, same thing. So in Windows, both devices look the exact same as well.